That's God, right? That's Hawking's mind of God, it really is. This is a conscious computer, okay, at the omega surface in our future. See, there's our Aristotelian final causation backwards through time. And so there's William Blake. And wait, I'll skip all the technical. Okay, this is a picture from MIT. Now this is a picture. Now what this is kind of a. This is in Scientific American. You know, it's not astounding science fiction. It's Scientific American. And what this is, it's just a representation of the surface, what's called the event horizon of a black hole. And he's showing it's pixelated. It's sort of like it's like a little computer. It's actually computing. It's an information processing machine. It has what's called entropy and information. And there's a whole theory of this. And this is now mainstream physics. Okay, but this is us. We're looking at a black hole in space, and we're outside the black hole. But it's a computer. And then Stephen Hawking, back in 1973, and a guy named, I think, George Ellis, one of the guys he worked with, they said, well, if this thing were, if the black hole horizon is a computer, then this cosmological horizon, they knew mathematically there was a cosmological horizon even back in, well, they knew it was a mathematical possibility back in 1973. They didn't know about dark energy, so they didn't know our universe actually had such a horizon. But they were saying, if you know, in a mathematical universe that was a solution of Einstein's equations, if it had such a horizon, it too would have the same properties, except we're inside the thing. See, this black holes are small, relatively small, and we're outside. You know, it's a collapsed star, say, but the surface of the black hole is a computer. It has what I call holographic properties, in what's called the de Sitter space-time, we are inside this thing. We're inside the surface and outside the surface, but it's still a computer. It's still a horizon. Now, as it turns out, at that time when Hawking and these guys were writing, they thought there's something in Einstein's theory called the cosmological constant that Einstein had in his original papers in general relativity around 1916. And everybody thought the cosmological constant was zero. See, but what the dark energy is, it's a positive cosmological constant. It's a very small number, but it's a positive cosmological constant. And once you have, and that's from the data, that's from the Type 1a supernova. Okay? So we now know, which we didn't know until 10 years ago, roughly, and we now know that in fact we are inside such a horizon. So instead of, you know, just imagine you're inside at the center of this thing, so to speak. Okay, and then, well, it turns out it's a computer, and it turns out, but it's a computer of future. See, it's sending. There was this theory of Wheeler. There's John Wheeler was a famous professor at Princeton. In fact, Cheryl met Wheeler. He was Richard Feynman, you know, the famous Richard Feynman. He was Feynman's teacher at Princeton, and they were now John Wheeler died just recently in his 90s. He was the inventor of nuclear fission with Niels Bohr. Bohr, you know, back in the 30s. So we're talking about, these are like, you know, important men. Okay, and in fact, I remember. Well, in any case, so he got the idea in 1940. In 1940, right before World War II was starting, Feynman's a young graduate student with Wheeler, and they're, you know, doing these crazy things, and they got the idea that in electrodynamics, that not only do you have influences from past to future, but you have to have what's called the advanced potential from future to past. This advanced teleological. So they first introduced the efficient cause, and it turns out then you know, the war happened, and everybody all went to Los Alamos and made the atomic bomb and all that. And then what happened was after the war, this guy named Fred Hoyle, who was an Englishman, actually I guess he's from Wales, Yorkshire. He's a Yorkshireman, and he was a professor at Cambridge. And in fact, Stephen Hawking has the professorship at Fred Hoyle. But Fred Hoyle used to come down to La Jolla, where I was a graduate student all the time. And so I got to know him a little bit. And so Hoyle took the Wheeler-Feynman idea and developed it even further, and developed, you know, applied it to quantum mechanics and cosmology. So Hoyle set up the basic equations for this kind of cosmological horizon, and that this future horizon would be influencing us from the future, backwards through time. So there's your efficient cause. And not your efficient cause, your final causation. But now it turns out, one of the big mysteries of the world is, why do we get older? It's called the arrow of time, irreversibility, second law of thermodynamics. So the issue is, why do we age? Why do we age? Okay, and this is actually a big problem in physics. That people, in fact, Ludwig Boltzmann, back at the turn of the century, got in such he committed suicide because he was considered a crackpot by his peers because he was like ahead of them. Okay, he actually committed suicide, I think 1906, and it turns out he was right. He was right. So, but in any case, so there was this arrow of time problem, and in fact, there's a recent book just came out. By, well, how are we doing on time?
We got plenty of
Okay. With a recent book.
Half an hour.
Oh, okay. A recent book has come out by a guy named Sean Carroll. He's a young, bright young guy. He's a young professor at Caltech. And the title of his book is From Eternity to Here. It's a popular book. It's like a bestseller. Popular book. It's a great title, From Eternity to Here. Yeah, of course, it's a play on From Here to Eternity, right? You know, with the movie From Here to Eternity. But From Eternity to Here. But where is eternity? I mean, we know eternity is not in the past. Goes by, this guy knows this, you know, he's a cosmologist, so he knows all this stuff, right? So eternity is not in our past because we know our universe began 13.7 billion years ago. It's pretty, you know, and that's a number that's accurate to about 2%, actually better now, less than 1% error. And you know, that's why it's called precision cosmology. Okay, this is so NASA is paying off because we're getting information like that. So where's eternity? Eternity's in our future. If anything, in the future, if anything's going to be infinite, eternity, it ain't going to be, we know the past is finite. We know we're only 13.7 billion years from the creation of time as understood in physics, okay? From the creation of the universe. So he's saying eternity to here, that's sort of saying backwards in time, like final cause, right? Except you read his book, there's nothing in there. It's like God in the New Physics with Davies. He'll probably get $1 million too from the idiots at Templeton Foundation because he's eternity here, like causation. You know, so you can't tell a book by its cover. So the book is a big letdown because you look at the book and it is a good book. He explains the history and all that, and he's a fairly good writer. And he just states the problem. He says, well, I don't have the answer. At the end, you read through 500 pages, no answer there. Okay. So, all right. Okay. So the point is this, that because this future horizon is like a hologram, like a plate. You know, if you have what a hologram is, you have information on a two-dimensional glass surface. You shine a laser beam through the glass plate, and what do you see? You see a three-dimensional image. Okay? Guess what, folks? You're all hologram images. That's the idea. It's a crazy idea. It's crazy enough to be true. So the picture that's emerging, and this is very consistent with Teilhard de Chardin's philosophy, that there is this computer, it really is a computer. Actually, it exists even now. Let me get back to that picture. Where is that? If you look at this, I mean, say way here, in this picture, this is from Tamara Davis's PhD thesis. So we're at this point here. So this is like what's called constant cosmic time. So you see here, the mustard color, this is where our future horizon is now, so to speak. There's a cosmic now. You can actually talk about a global cosmic time in these general relativity solutions, cosmological solutions. So we are here, and our future horizon is a sphere over there, but that sphere is not influencing us because the speed of light is finite. So we're actually being influenced from the future. See, this is what's called our future light cone. On this diagram, light rays go at 45 degrees or 135 degrees. That's, you know, it's rigged that way. It's just a representation. So what's happening is here, it's at this point, the intersection of what's called our future light cone with our future event horizon. That point, and that's going to be a spherical shell, so to speak, at billions of light years away from us. But it's information being radiated backwards through time through the wheel of Feynman effect, this advanced potential effect, that's creating us, so to speak. We are kind of, it's as though we are, you know, it's like those movies, The Matrix and 13th Floor. You know, that's the picture. We are actually being computed. We're three-dimensional images, conscious though, see, we're